So we will wait for 2 minutes and then we will start.
Okay, so right now we are 101, so we are 100 plus. So we will start the today's session about the practicals. Now you had seen the syllabus in which it is mentioned that acylation. So I will take the acylation acetanilide from aniline. Then second one of same is res acetophenone from risolidol. And also, if you had seen the number 8, it is written Friedel-Crafts reaction, and in which two preparations are given, that is the 4-methylbenzophenone and preparation of aspirin. So now tell me, what is the difference between the practical number 3 and practical number 8? Can someone? What is the difference between practical number 3 and practical number 8? Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes.
Yes, thank you. So practical number 3 is titled as acylation and practical number 8 is titled as Friedel-Crafts reaction. So what is the difference in these two practicals? Tell me. Is there anything? Is there any difference? What is your answer? Yes or no? Is there any difference? Say yes or no. આ બધાને કોરોના થયો છે?
No, sir.
Ah. So we are safe. So what do you say?
No, sir.
So it is not same. Okay, fine. Who else?
There might be reagent would be changing in practical 3 and practical 8.
Okay, reagent would be changed in practical 3 and 8. Good. Who else? Yes. Anybody else?
એસાઇલેશનમાં RCOCl એડ થાય અને
Okay.
ફિડલ કાપમાં આલ્કાઇલ ગ્રુપ એડ થાય.
Okay.
Esterification.
Esterification. Sema.
Aspirin.
Aspirin ma. Okay. Good. બીજું કઈ ખાસ લખી જણાવવા જેવું? Great. So both the reaction comes under the acylation. Okay, 3 and 8 are acylation, and acylation is named as Friedel-Crafts acylation. So Friedel-Crafts alkylation and Friedel-Crafts acylation. So two things are different. Alkylation, where alkyl group can be introduced, whereas in acylation, acyl group should be introduced. So alkyl groups, give example of alkyl group.
Methyl, ethyl, propyl.
Okay, great. So when you are introducing methyl group CH3+, so that is the alkylation. And what is the acylation? Acyl group means what?
RCO.
Can you repeat, Shimran?
RCO group we have to introduce.
RCO group required to introduce. Okay. And Nishi Thakkar, you were saying something?
Sir, acid chloride.
Acid chloride. So first listen. Whatever answer you had given, it is correct. But you can just listen. What is acyl group? What is the structure of acyl group? So somebody has said, or Simran has said, RCOCl. Simran?
Sir, RCO is the acyl group. And
RCO
Cl will
is
be
the-
removed.
Okay, RCO is the acyl group, and Nishi has said CH3COCl. So it is a reagent to get the acyl group. But if you look at it is the type of electrophilic substitution reaction. So when we are saying electrophilic substitution reaction, then it must be a electrophile. So now what do you say, Simran? Correct it now.
Sir, might be carbon atom in RCO group will be positively charged.
Correct, because electrophile must have the positive charge. Okay, so here RCO plus. And Nisi, in your case, what would be the electrophile? Nishi?
Yes, sir.
Yes. So what is electrophile in your case?
RC plus.
No, you have
RCO
said
plus.
CH3CO plus. So R is your CH3. Okay. So here, what is electrophile now?
R plus.
No, CH3CO plus. Correct?
Yes, sir.
So everybody say yes, we got the acyl ion.
Yes, sir.
Yes.
Yes, sir.
Everybody say yes. Huh?
Yes, sir.
Yes, sir.
Good. So it means that the acyl ion so it is a electrophile, is it? So CH3CO plus, is it? Now have you heard CH3CO minus? You are studying the Friedel-Crafts acylation in which CH3CO or RCO plus you have identified as a electrophile. So now tell me, have you heard CH3CO minus? Yes or no, maybe? सुना है, नहीं सुना है, अनसुना है?
Sir,
Yes.
if instead of chlorine, if we have any other atom which has lower electronegativity than carbon, so in that case we can obtain
So it is
RCO
there.
minus.
Yes. Okay. So CH3O minus, CO minus is also there. That is known as the acyl anion. And CH3CO plus is acyl cation. So CH3CO minus, that is the acyl anion, that is the like not normal by the way, but that is known as polong. Say everybody polong.
Polong.
Everybody માં સિમરન એકલી જ આવે?
Ampolong.
Very good. So along with this practical, I am also teaching you the German word. Is it? So at least you can have the one word you learn that is in German language. So polong is not the English word, it is the German word. Okay, and the meaning of it is the reverse of polarity. And reverse of polarity means CH3CO minus. So that is the not normal by the way, but anion is there. You will learn that in the coming semesters. Okay, fine. So here we are talking about the Friedel-Crafts acylation. So in which it is required to introduce the acyl group, and it is the electrophilic substitution reaction. So acyl cation means CH3CO plus, that is your electrophile. Now tell me. Now tell me. How do you get, or what reagents can be possible to produce the acyl cation? What reagents are there to produce the acyl cation?
RCOCl and anhydrocl 3.
So when you are saying RCOCl means it is the general form. So what is the reagent, actual compound, actual reagent that exists? RCOCl is not exist. It is general form.
Anhydrous AlCl3.
That is the catalyst. But from there you will not get the CH3CO.
Acid chloride.
Yes?
Acid chloride. Acid chloride.
Acidic chloride. So what is the example?
RCOCl.
That is the general form. It is a acid chloride. But what is the reagent that exists? તમે લેબમાં જશો ભૂલથી આવતા સેમેસ્ટરમાં કદાચ તો what should I give you? હું તમને RCOCl ક્યાંથી બોટલમાં નહીં આપી શકું.
સર તમે એસિટિક એસિડ સપોઝ તમે લો તેની અંદરથી PCl5 નાખો ત્યારે Cl એ RCOCl ફોર્મ જનરેટ થાય.
હા, so who said? Arvind.
સર યસ સર.
Arvind, you have said very nicely. I really appreciate. But my question was not that how do you produce the CH3CO plus. My question is what is the reagent? That's it. So what is the reagent in your case, Arvind?
PCl5 sir.
No.
Chloride.
Ethyl chloride.
Acetyl chloride.
It is CH3COOH, acetic acid.
સર ખબર ના પડી.
It is the acetic acid. આપણે તો CH3CO ગ્રુપ શેમાંથી મળે એટલી વાત કરીએ છીએ. કેવી રીતે બને એવી નથી વાત કરતો હજુ.
હા સર ગોટ ઇટ. ખબર પડી.
પડી ગઈ ને?
હા યસ.
એટલું સરસ અરવિંદ. તને ખબર પડી જાય તો 105 તો બીજા છે જ.
સર તમે એમ કહેવા માંગો છો કે આ ફોર્મમાં એક્સિસ્ટ ના આપણે એસિટેટ જે આયન હોય એની અંદર એને બેલેન્સ કરીને રહ્યું એમ ને?
નો, સી RCOCl તમે કહો છો તો RCOCl is not existing.
અચ્છા.
પણ તમે કહો કે CH3COOH it is existing.
યસ.
અને એમાંથી CH3CO plus can be produced. તમે કહો માણસો. But here it is a general. When you are saying Dilip, then he exists as a real person. Correct? એટલે તમે ડિપાર્ટમેન્ટમાં આવો તો તમે દિલીપને પકડી શકો કે yes, here he is. બરાબર? So that can be real. Is it? When you are saying RCOCl, it does not exist. It is representing the general form of the acid chloride. Correct, everyone?
Yes, sir.
Say yes. ખબર પડી ગઈ એમ?
Yes, sir. Yes, sir.
Yes, sir.
Good.
sir.
Very good. So, Arvind has said very nice reagent that acetic acid, CH3COOH. Okay, so this is the one of the reagent to produce the acyl group. Okay, what else? What other reagents are existing?
Sir, maybe
Nishi?
benzoic acid.
Benzoic. Okay, benzoic acid. See, it is there. It is having the carboxylic group. Okay, but when you are saying that, it is like in the acetic acid also, by the way, acetic acid also, and in the benzoic acid also, it is the H plus is more reactive. It is acidic. Okay, so it is difficult to produce the CH3CO plus and CH3CO plus from acid. But right now you can consider that, because there are some reactions where cleavage of the OH bond, that is also there. Okay, CO bond actually, cleavage of the CO bond in which OH minus can be released. So that can be there, but very few reactions are there. But it is not the, it is existing, by the way, but it is not utilized for the acetylation. Okay, but good that you brought this point. What else? Nisi, you have said very first time the name of the reagent. In the first conversation itself, Nishi, you have said, you have named actually. What was it?
Sir, can
Somebody,
you repeat?
in the first conversation itself, you have named the reagent. જ્યારે પહેલી જ વખત તમે બોલ્યા ને ત્યારે તમે reagent નું નામ બોલ્યા હતા. Yes?
Acid chloride.
Acetyl chloride. Okay, acetyl chloride, CH3COCl. So that is the one of the reagent. What else? And it is very reactive, by the way, highly reactive. What else? Have you heard the word benzoyl chloride? સુન્યું છે?
Yes, sir.
Yes, sir.
Okay, so benzoyl chloride is also considered as a acetylating agent. Have you heard the word acetic anhydride?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that is also very good acetylating agent. By the way, it is the banned product. એની ઉપર સંપૂર્ણ રીતે પ્રતિબંધ મૂકવામાં આવેલો છે. But we are so lucky that we are having, I mean, Department of Chemistry is having the license to use the acetic anhydride, because it is used in the preparation of explosive material. But also it is easy to prepare acetic anhydride from the acetic acid. So these are the acetylating agents. So here the acetylating agents are acetyl chloride, benzoyl chloride, acetic acid, and acetic anhydride. Correct? તમને ભૂલથી ક્વેશ્ચન પૂછવામાં આવે એક્ઝામમાં કે you can name the acetylating agent. A, CH3COCl. B, benzoyl chloride. C, acetic acid. D, all the above. કયું બોલશો તમે?
All the
All
above.
the above.
Very
All
good.
the above.
ઓહો, તમે તો ચેટલા હોશિયાર હવે તો. All the above. બરાબર? Good. તો આવા ભૂલથી તમને ક્વેશ્ચન આવી શકે એક્ઝામમાં. બરાબર? હાલ પૂરતું કદાચ ઓફલાઈન પ્રેક્ટિકલ લેવાય ખરા, ભગવાનની દયા અને આશીર્વાદ અને કોરોના જો બચી જાય તો. So now everybody Are you clear about the acetylation and acetylating agents? Say yes.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
Good. Very good. So now we will start with the practical. That is the first practical, acetanilide from aniline. Acetanilide from aniline. Now I am sharing the board. So okay, Patel Shreya, welcome. You are welcome after 30 minutes in this meeting. So can everyone, is it visible, the whiteboard?
Yes, sir.
Yes, sir. Yes, sir.
Okay. હું દેખાઉં છું ભલે કલર થોડો ડાર્ક હોય પણ.
No, sir. Yes, sir.
અરે
No,
હું
sir.
નથી દેખાતો. હા તો બરાબર.
Yes, sir.
હા કોણ ના બોલે છે ભલે એટલો ડાર્કે નથી કે હું દેખાઉં જ નહીં. લાઈટ મૂકી છે બરાબર. Okay, got it. So now we can have the first preparation, that is the preparation of acetanilide from aniline. Okay, acetanilide from aniline. So now you are familiar with the structure of the aniline. Can everyone familiar with the structure of aniline? Say yes.
Yes, sir.
Okay.
Yes, sir.
Good. So this is the aniline, and preparation is what it is required to prepare the acetanilide. Okay, it is required to prepare the acetanilide. Just a minute, huh? Okay, fine. Now it is not. Okay.
સર મ્યુટ થઈ ગયા તમે.
Huh. So NH CO CH3. Okay, so this is a product. This is aniline.
सर
This one is the aniline, and
स्क्रीन
this
नहीं दिखाई दे रही है आपकी
screen નથી દે.
इसमें से लोड नहीं हो
દેખાય છે સર
દેખાય છે
नहीं दिखाती सर
દેખાય છે સર
Acetanilide દેખાય છે?
પ્રોબ્લેમ હતી સર
हाँ सर
હા સર
હા, એટલે નેટવર્ક વીક હશે ને તો બોર્ડ નહીં દેખાય. નેટવર્ક વીક હશે ને તો બોર્ડ નહીં દેખાય. So acetanilide. Okay. Now if you just look at NH2 was there and now you are introducing the COCH3. So now you can have any of the reagent to produce the COCH3 group. So here we will utilize any of the reagents. So for this reaction, it is recommend to utilize the acetic anhydride. Acetic anhydride. Okay. So acetic anhydride, in presence of the acetic anhydride, the aniline gives the acetanilide. But in this case, it is advisable to use the sodium acetate in presence of the aniline and acetic anhydride to protect the oxidation of the aniline.
सर व्हाइट बोर्ड नहीं देखा तो it's like white boarding is in progress એવું લખાઈને આવે છે.
Okay.
દેખાય છે સર
દેખાય છે સર
દેખાય સર मैं WhatsApp કર્યું મેં તમને એવું એરર આવે છે.
ના પણ WhatsApp તો હું ના જોઉં ને, હું બેમાંથી એક જ કામ કરીશ ને ધ્રુવ.
તારું નેટવર્ક સ્લો છે ભાઈ.
જો નેટવર્ક વીક હશે ને તો નહીં દેખાય. નેટવર્ક
વાઈફાઈ છે ઓફિસ નું should work.
હા, that is according to us. According to you, it is a strong network, but it might not. અને બીજો એક રસ્તો છે, મારો વિડિયો મને જોઈ લીધો હોય તો બંધ કરી દો અને બોર્ડ ઉપર ક્લિક કરો તો that also can be possible.
ऐसा दिख रहा है white board is not supported in all ऐसा तो फोन
So once again I am sharing. So you will get clear idea about it now.
Sir, now it's visible.
Okay, correct. So now it is visible, everyone.
Yes, sir.
Say yes.
Yes, sir.
Okay.
Yes.
Yes.
So should I required to write the reaction again?
No, sir.
Sir,
So
if you
aniline.
can,
Yes.
if you can, please
Okay.
rewrite the reaction.
Yeah. Fine. So what we have, what was the, just a minute, this pen okay. So what was written? That was the aniline in presence of the CH3CO twice O in presence of CH3C sodium acetate. It gives the, અરે આ પેન બહુ મોટી છે, ફેટ છે, NHCOCH3. Okay, so this was the reaction, general reaction that was written. Now just wait, this pen is very fatty. No, that will change the color. Okay. No, still it is. Okay, done. Okay. Yes. So this was the reaction, preparation of acetanilide from the aniline. Now, am I required to go for the calculation, or I can skip the calculation? Because I think you have completed all the practicals of MSc semester 1 except these 4. So tell me. Should I go for the calculation part? Hello?
No, sir.
Okay. So I can go directly. Thank you for that. So you can calculate that accordingly. So you can take the reagents, calculate the molecular weight. Then if density is required in any of the compound, then write down the density. You can find out the number of moles present in that reaction mechanism. See, number of moles, about the moles utilized in the reaction, that will be that we will get an idea by the reaction mechanism. Okay, then require amount of weight, that can be 1 ml or 2 ml or 3 ml, whatever. So that weight or ml can be given by the examiner. So in examination you always ask, sir, how much amount will I take? એવું જઈને પૂછવાનું સરને. અને સર હોશિયાર હશે તો એ પહેલા જ કહી દેશે કે everybody start your reaction with 2 gram. અને મારા જેવા હશે તો એ કદાચ ભૂલી જાય તો પછી તમારે પૂછવા આવવું પડે. So by calculating this, by getting the amount, you will able to calculate the rest of the amount of the reagents. So reagents, molecular weight, density, number of moles.
સર વોઇસ નથી આવતો તમારો. નેટવર્ક તરત નીકળી ગયા.
સર નીકળી ગયા લાગે છે.
ના ના પ્રતીક
બોલો ને ભાઈ. કોક મેસેજ કરો સર ને.
સર ને કોઈ પર્સનલ મેસેજ કરી દો.
ફોન આવી ગયો.
Wait. We are connecting.
हेलो सर.
Hello? Yes,
Okay.
please wait. Sir is connecting.
Okay, I am back. શું શેર કરવાનું હતું? Okay. Now, okay. Screen again visible.
Okay sir.
Yes.
Okay.
Yes sir.
Good. So aniline is dissolved in the HCl. So what will happen? Aniline will form the quaternary salt so that the solubility of aniline can be increased. So N H was already there, and now this H comes from where? HCl. That is possible by sharing of the electron from the nitrogen. So now actually the valency of nitrogen is 3. Now here it is 4. So this is the positively charged. And Cl minus is there. So it is the anilinium salt. So this required to increase the solubility of the aniline. And also I have said that the aniline is oxidized in the N oxide. So to protect that oxidation of the aniline, sodium acetate is also utilized, and it is also utilized as a buffer solution so that pH can be maintained. So sodium salt is the water soluble, so you can prepare the solution of the sodium salt, sodium acetate in the water so that it ionized, and you will get the Na plus and acetate minus ion. So what will happen here during the reaction? What it is going to form, that is the NaCl plus CH3COOH, because this H will be abstracted by the acetate ion. Okay, so that is why you can say that buffer solution is what? Acid and salt of that acid. So acetic acid plus sodium acetate, that is the buffer solution. Okay, so that is why the sodium acetate is also utilized. So my dear students, what is the role of sodium acetate here in this reaction? To protect the oxidation of aniline. If aniline is oxidized, it forms the N oxides. That is the first reason. And second reason is what? It remain as a buffer solution, so that pH should not change, so that aniline should react freely. So this thing is happened now. Okay, so now we have taken the acetic anhydride. Okay, so here it is the aniline. This is our aniline, H, and this is the 2 dot, that is the lone pair of electron. And now we have taken the acetic anhydride. So it is CH3, C double bond O, O, C double bond O, and CH3. This is our acetic anhydride. Correct? So this acetic anhydride is taken. Now what will happen? This is the 2 carbonyl group involved and both are same. So reaction will initiate. So this pi bond of the oxygen, a pi bond between the carbon and oxygen will get cleavage, so that being more negativity of oxygen, the electron of carbon will be taken up by the oxygen. So here what do we get? CH3 CO minus, pi bond is cleavage, O minus. Now electron of this carbon is taken, so that is why carbon will become the positive charge, O, C double bond O, and CH3. Correct? So this carbocation is formed here. Carbocation is formed.
हेलो सर.
Yes sir.
એક વખત રિપીટ કરો ને સર.
હા, શું રિપીટ કરું?
આજે આ કેટાયન ફોર્મ થયો એ વાળું.
હા, કેટાયન ફોર્મ થયું એ વાળું હું પાછો રિપીટ કરું, બરાબર? તો પાછું રિપીટ કર્યું જો.
હા સર.
હા, કેટલું મસ્ત રિપીટ કરું જોજે. O, O, C double bond O, and CH3. This is my reagent. Okay, acetic anhydride. Is it? And
yes sir.
Okay. And now this pi bond are there between the carbon and oxygen. 2 carbonyl groups are here. This is and this one. Okay, so any of the carbonyl group can take part in this reaction. So I am taking the carbonyl group this. So what will happen? There is a pi bond. So this oxygen being a more electronegative, pi bond will cleavage and electron will be taken by the oxygen, because oxygen is more electronegative than the carbon. Correct? So what do we get? CH3 CO minus, and this become the positively charged, because this electron is taken by the oxygen. So I will clearly mention here. No, with red I can mention. Here it is electron and this is the another electron. Okay. So this electron is taken by the oxygen and rest will remain as it is. O and CH3. Clear now?
Okay, sir. Got it. Thank you.
Okay, so this carbocation is formed now. Okay. Now here there is no carbon ion, but of course nitrogen is having one lone pair of electron and nitrogen is having tendency to share the electron with the deficient electron. So this nitrogen will share its electron with the carbon deficient carbon atom. So what do we get now? Here we will get this N. I am writing this H this side H, and now see this new bond is formed between the nitrogen and this carbon atom. So this is carbon, this carbon, and here it is the this is carbon. I am showing with the different colors so that it is possible. This is the new bond developed between the nitrogen and carbon. Now see here it was the O minus and here it is the CH3. So I have written CH3, and now what is left? O, C double bond O, CH3. Correct? And this nitrogen has shared its electron. So now it is possible to put the positive charge. Okay. Now what will happen in the next step? So this oxygen will share its electron again with the carbon atom. Okay. So at that point of time, this bond is going to cleavage. Which bond? Carbon oxygen. Carbon oxygen bond is going to cleavage. So this will going to cleavage. So it means the electron of this carbon is taken up by this oxygen. So now what we are getting, that is the aniline. So what we are getting, that is the aniline. So this is the condition H and C. Here it is. I am writing this part C. Now oxygen has shared its electron. So now C double bond O is developed here. C double bond is, and CH3 is there. And plus the another portion is what? That is the O minus, C double bond O and CH3. Clear everyone? Here it is the positive.
Yes, sir.
Yes. Okay. So this we received at this junction. Now here it is the quaternary salt of the ammonium. So nitrogen is plus. So now this oxygen will abstract the proton from this complex. So what is going to release? CH3COOH from this. Okay. And what else is left? That is the NHCOCH3. And that is a product, acetanilide. Okay, this is a product, acetanilide. Clear about the reaction mechanism?
Yes, sir.
Yes, sir.
You can say that we have utilized the aniline, 1 mole of the acetic anhydride, and 1 mole of the sodium acetate. So in calculation, you will use 1, 1, 1. I mean aniline 1 mole, acetic anhydride 1 mole, and sodium acetate 1 mole. So accordingly, you can go for the calculation. Now, method how to prepare it. So first you can take the aniline. Okay, you have taken the aniline. So what is the color of the aniline? What is the color of aniline?
Reddish brown color.
Sir,
Okay.
sir,
Yes.
your form ma colorless હોય.
Correct.
Your
So
your form
normally
ma
you
color.
will see brown in color or reddish in color in the laboratory. Okay, but the original color of aniline is colorless. It is colorless compound. So brownish color is obtained. It means that it is impure aniline or it is oxidized. So to remove that impurities, so first aniline should be dissolved in the HCl. Aniline should be dissolved in the HCl, and you can add the charcoal. You can add the charcoal and heat this solution. Heat this solution and filter it. So here you will get the charcoal, coal and other impurities, and you can collect the filtrate here. So this solution is now clear solution. So this solution is taken in the RBF. You have taken this in the RBF. Okay, RBF, in RBF what is the, it is the solution of the aniline. It is aniline and HCl. And now you can prepare the sodium acetate solution in the water. You can take the salt and pour the water, H2O. So now this is the solution, sodium acetate solution. So now this should be poured in the RBF. So now in this RBF, what is there? What is there? So aniline plus HCl plus sodium acetate. Okay, sodium acetate. This solution is there in the RBF. Clear everyone so far?
Yes,
Say
sir. Yes, sir.
Very good. Okay. Now you can take the acetic anhydride. It is a liquid. Acetic anhydride in the test tube. You have taken this acetic anhydride in test tube. And now you can pour this solution in the RBF. Dropwise. Dropwise with the constant stirring. Okay, અહીંયા તમારે stir કરવાનું આને. બરાબર, you can stir this solution here properly. So this addition will may take 15 to 20 minutes. And then once it is stirred properly, then you can stir further for 5-10 minutes, or you can stir till your hands can be shaking. So after that, you can pour the solution or transfer the solution in the beaker that contain the ice. Ice. And now you can transfer this solution in the beaker that contain the ice. So here you will see white solid of the acetanilide. White solid of the acetanilide. Now you can go for the filtration. So you can filter it here with the filter paper. So filter it. Here you will get filtrate and your product will be here. This is your product. This is your product, white in color. And some of the product can be taken in the test tube and add the distilled water. Heat it slightly, so get the crystals, white crystal. Okay, you will get the white crystal of the acetanilide, and that is having the 114 degrees Celsius melting point. So this is all about the acetylation and preparation of acetanilide from the aniline. Clear, everyone?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so I hope that whatever we have discussed, it is clear for you. Say yes.
Yes, sir.
Yes, sir.
Good.
Yes, sir.
Yeah, good. Say thank you.
Thank you.
Thank you, sir.
Good.
Thank you, sir.
Thank you.
Thank you, sir.
Okay, great.
Thank
So
you,
now
sir.
we will go for the second practical. Okay, we will go for the second practical. That is the preparation of res acetophenone from resorcinol. And my dear student, now I am going to invite Siddhi Panchal, and I have introduced you during the offline. I am there with you, by the way, but I am giving to her to discuss the second practical. Okay, that is the res acetophenone from resorcinol, and it is also the acetylation. Clear, everyone?
Yes,
Okay.
sir.
Yes, sir.
Yes, sir.
Okay, so wait for a minute.
Thank you, sir. Good afternoon, everyone. Am I audible?
Yes, ma'am.
Yes,
Yes, okay. So our preparation, the second preparation for today is res acetophenone from resorcinol. As sir said ago, this is also a acetylation process, and our general equation goes is this is resorcinol, and the acetylating agent which we will be using is ZnCl2 and glacial acetic acid. So ultimately the product which we get is COCH3. So this is resacetophenol, or as we go with the IUPAC nomenclature, it is 1,3-dihydroxyacetophenol. Am I clear to you till here?
Yes.
Okay,
Yes,
so now
ma'am.
we will, okay, thanks. From here we will go to the reaction mechanism. This includes first the preparation of our acylating agent, that is as earlier sir said, the acyl cation or the electrophile. So while adding these are the reagents. So while adding them, that is ZnCl2 plus, after as we have calculated the mole ratio, we have find out that the glacial acetic acid which we will use consists of 2 moles. So we will take 2 moles of glacial acetic acid and providing heat to it, we get CH3, C double bond O, O, Zn. This is a Zn salt which is formed along with 2 moles of HCl. Now here, as the lone pairs of this oxygen are present here, this oxygen will abstract electrons from here, and so to satisfy this bond, this electrons will also go there, and hereby our acetyl cation is formed, which is CH3CO plus, and the rest structure which is formed is the O minus, with rest is the same, CH3 double bond O. Now we will be utilizing these 2 bonds of HCl. So one of from these 2 moles of HCl is utilized here. This we will write as it is because we have already formed our electrophile. This hydrogen gets attached over here, and the same mechanism which was carried out here will be carried on here also. And so we are left it with OH, Zn, now again the second mole of HCl which was left will again be utilized here. The second mole, our electrophile is as it is, and we get the ZnCl2 which bonds like this. So it is, and this H forms the acetic acid, and we are left with this OH minus. Now going further, now as we have made our acetyl cation, so we will utilize this in the formation. Now our raw material which we selected was the resorcinol, Now as OH is the para-directing group, this OH acts as the para-directing group, so the para position over here will be the active site. So this electron pair donates its electron here. So we get a structure. Now this acetyl anion cation which we made will attack here, and we are left over with our product where it is attached now. So it is CH3 double bond O. The OH is as it is. Now as we can see, this positive charge will now be satisfied by the H bond hydrogen atom releasing. So we can release a proton over here, this one, and a stable product of ours is there, which is the res acetophenone. And at last, this OH will bind with this OH minus and this H, and they will form H2O. So in the end of the reaction, as we can say, we will be left with 1 mole of our product, 1 mole of ZnCl2, 1 mole of acetic acid, and 1 mole of water. Am I clear with the mechanism? Am I clear?
Yes.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so can we go for the procedure now?
Yes.
Yes, ma'am.
Okay. Okay. So for the procedure, we will take first the ZnCl2 and dissolve it in our glacial acetic acid and provide heat to it. So we have the dissolved ZnCl2 in the acetic acid over here with heating. And then to this heated mixture, resorcinol is added, and the reaction is kept to heat at 140 to 150 degrees centigrade for 20 minutes. After 20 to 30 minutes of heating, we can let it cool down to room temperature. And meanwhile, while preparing the we can prepare the dilute HCl, which is then added to it. So we have our mixture of ZnCl2 and acetic acid. Then we have added the resorcinol, and now after cooling it, we will add dilute HCl to it, and finally we are left over with a yellowish orange color of our product, which is in the crude form. So this is a yellowish orange colored res acetophenone, which is crude. So now we need to recrystallize it. Recrystallization is done so that we can get the pure product. We need to do the recrystallization with the help of boiling ethanol. So we can heat the ethanol and dissolve our res acetophenol product in it and let the ethanol dry away. So we get crystals of pure product. And ultimately, at the end, to confirm that we have got our desired product, you can measure its melting point, which comes out to be 142 to 144 degrees centigrade. Anybody, any doubts with the process?
No, ma'am.
And any other doubts with the overall practicals or anything which you didn't get?
Is it clear for everyone?
Yes, sir. Yes.
The reaction mechanism and the procedure of the acetophenone.
मैम
Yeah.
मैम ये एसिटिक एसिड और ग्लेशियल एसिटिक दोनों सेम है क्या मतलब फर्क क्या है इन दोनों में?
नहीं, दोनों फर्क है. Glacial acetic
क्या
acid
फर्क?
is the purest form of acetic acid. So we need to make glacial acetic acid from acetic acid. So you take the normal acetic acid, COOH, and then you heat it. And after heating, you can cool it down in ice to form the glacial acetic acid, which is pure one, and it is anhydrous in nature. Okay.
Okay.
So you might have heard the glacial Antarctica. Okay, so that word is derived from there actually. Okay, anything else regarding the acetophenone? Is it clear, everyone?
Yes, sir.
Yes, sir.
Yes.
Oh,
Yes,
okay,
sir.
good. So Siddhi is pursuing her PhD and she is about to complete her PhD, and she has explained this procedure very nicely, and every year she is taking, but since this 1 or 2 years due to the pandemic 19, it was not feasible to continue the physical practical, but whenever it is possible, they will interact with you and you can interact with them so that it gets clear for you during the practical hours. Okay, so I congratulate Siddhi, and thank you, Siddhi, for the explaining nice practical.
Thank you very much, sir. Thank you, everybody.
Okay, now the third practical is left. That is the preparation of aspirin. And that is also the acetylation process, by the way. But somebody has said that it forms the ester. So correct. When it reacts with the OH functional group, it gives the ester. Okay. So here again I am inviting Dr. Nikita Mishra, and I have introduced her also during the offline classes. So she is going to discuss the third practical of today's session, that is the preparation of aspirin. And she has completed her PhD from the same department under my guidance, and now she is working as a professor here in this department. So welcome, Dr. Nikita.
Good afternoon, everyone.
Good afternoon.
Am I audible?
Yes.
Yes, ma'am.
The screen is visible?
Yes.
Yes, ma'am.
Yes, few were there in my assignments and seminars. So few have interacted me, and few of them maybe not. So today we are going to see the third practical, that is preparation of aspirin. And the aspirin we will prepare from salicylic acid. So first we will take So first we will take salicylic acid, that is having OH and COOH. That is salicylic acid. So this is the general reaction in which we will write salicylic acid with CH3CO whole twice O, that is acetic anhydride. In another way we can write CH3 C double bond O, O, C double bond O and CH3. Then after, what we will get is, by adding H2SO4 on heating, we will get the final product, that is OCOCH3 and COOH. It is known as aspirin. So now we will go through the mechanism. First, what we will take is salicylic acid, OH, COOH. What we have taken is H2SO4, that is sulfuric acid, as a dehydrating agent. So this H2SO4 will abstract the proton, and what we will get is O minus and COOH. Now we have taken acetic anhydride. In general reaction we had seen. So here CH3, C double bond O, C double bond O and CH3. So in this carbon will share its electron. So what it becomes will be CH3, C double bond O with positive charge. So this is again a cation formation. And the another will be CH3, C double bond O, O minus. Now here this O minus will share its electron with this carbon. So what we will get, so again what we will get is our product, that is O, CO, CH3 and COOH. What it is left is CH3, CH3, C double bond O, O minus. Now this O minus, and here that H2SO4 has abstracted the proton, that is minus H plus with the positive charge. So this positive charge and this O minus, what it becomes will be CH3, COOH. So what we can say is we have utilized 1 mole of salicylic acid, then 1 mole of H2SO4, and what we got is aspirin with 1 mole of product. So everyone clear? Any doubt?
No, ma'am.
So now we are going to through the procedure.
So is there any doubt in the reaction mechanism?
No, sir.
Okay, good.
So what we have to do is, first we have to take salicylic acid with concentrated H2SO4 in the conical flask. Then we have to add acetic anhydride portion wise. In this conical flask. Then you have to stir well this mixture. You have to stir and you have to keep it on 50 to 60 degrees Celsius temperature for 30 minutes. Then after, you can cool the reaction mixture and take the mixture, that the product, in ice or cold water. So after that you will get the crude of aspirin after the filtration. Then after, you have to do the recrystallization. That recrystallization can be done in alcohol and you will get your crystals. Product. So any doubt in this procedure?
No, ma'am.
Any doubt?
No, ma'am.
So thank you very much. Over to sir.
So everyone, clear the reaction mechanism and procedure?
Yes, sir.
Yes, sir.
Okay, good. So this was the third preparation that we have discussed, that is the preparation of aspirin.
Mute થઈ ગયા સાહેબ તમે.
It is Dr. Nikita Misra has not said anything, but it is used as a
Analgesic.
what is it?
Analgesic.
Analgesic.
Analgesic and antipyretic.
Yes, great. And like it is the immediate relief is getting when heart attack is comes. Okay, so those who got the heart attack, if nothing is there, you can give aspirin drug immediately. So it does not allow to clot to blood. Okay, so it is not allowing to clot the blood. So it is the very first remedy those who are getting the heart attack, is it? So we'll hope that we should not get the heart attack, and near and dear also will not get the heart attack, is it? So this aspirin is explained very nicely with Dr. Nikita Misra, and she is with us in Department of Chemistry. So during the practicals, offline practicals, you can interact with them so that it is easy for you to do the work. So I congratulate Dr. Nikita Misra for explaining this practical.
Thank
Okay.
you, sir. Thank you, everyone.
Okay, fine. So now the last practical of the acylation is left, and that is left with the preparation of 4-methyl benzophenol. It is left with the 4-methyl benzophenol. Okay. Now it is patented. This practical is having the patent. So it is you may not get the reaction method of this practical easily, because patent is there, and patent is from USA. But lots of benzoquinone derivatives can be prepared by using this method. So you will not get as it is. Okay. So what is the practical? So practical, the aim of the practical is the preparation of 4-methyl benzophenol. 4-methyl of benzophenol. So now if we can write down the reaction mechanism of it. So let me share the screen, whiteboard. Where is it? Okay. Yes. So whiteboard is there in front of you. So what it is, so we have to prepare the 4-methyl benzophenol, but from where? So it should be prepared from the toluene. Toluene can be the starting material. So here it is the toluene. So benzene and CH3. Toluene, and it is the acetylation, by the way. So here we need acetylating agent as a benzoyl chloride. So it is benzoyl chloride, COCl, in presence of the AlCl3 as a catalyst, and the reaction temperature is the ice temperature, that is the 0 to 5 degrees Celsius temperature, which gives the 4-methyl benzophenol. So this is our product. Okay, this is our product. So you will not get the reaction mechanism of this easily, because this reaction mechanism we have searched a lot, but it is not available. So you can remember this reaction mechanism while I am sharing this screen with you. So what do we do now? Okay, so I am starting the mechanism. This is a reaction. So toluene is reacted with the benzoyl chloride in presence of the AlCl3 as a catalyst at 0 to 5 degrees Celsius temperature, gives the 4-methyl benzophenol. Now I can proceed. Okay. So here, what should I take? So first of all, I will take the benzoyl chloride. Now, acetyl chloride and benzoyl chlorides are highly reactive. Even if you keep at the room temperature, they will start reacting. So it reacts also with the tears. So immediately HCl is getting formed, and that is why the irritation takes place. So this benzoyl chloride is dissolved in the CH2Cl2, methylene dichloride. So MDC. This is the solvent. Okay, it is a solvent. So this should be dissolved in it, and you can have the AlCl3. So what will happen? It will form the AlCl3 is Lewis acid. So it will form the AlCl4 minus, plus you will get the benzoyl cation CH3CO plus. So electrophile, that is the benzoyl ion, is formed in this step. Now you will take the toluene CH3. Now it does not have any functional group. The substituent is the CH3, but it is highly unreactive. So this electrophile will not react with the methyl group. This methyl group, is it? So actually the coupling reaction is going to take place. So this, the toluene plus the benzoyl cation CH3CO plus. So here I can show you in this form so that it is clear. This is the bond. Here it is. Okay, this is the bond. I can show you in this way. CH3 okay, this is our toluene. Okay, so what will happen? This pi bond is going to cleavage so that this will form the carbon ion as well as the carbocation. So CH3, and here what do we get? So here it will get the negatively charged. So this will become the positively charged, and the rest of the bonds remain as it is. Plus this is the carbocation. Okay, acyl cation. So now this is having the extra electron. This carbon is having the extra electron. So now this carbon will share its electron with the acyl cation. So now new bond is going to form between the carbon of the toluene and carbon of the acyl. So what do we get? We will get CH3. This is the ring. Okay, it is the positive charge. Okay, and now here it is the H, and this could be the CO. Yes, and the rest of the bonds will remain as it is. Okay, now by removal of this H plus, H plus will get released here. So H plus is released, so electron will received by this carbon atom so that it will fulfill its valency. So now we will get the ring complete with the bond and C double bond O and the ring. Okay. So finally we will get this product. Now here H plus is released. Here H plus was there, that is released from the toluene ring, and AlCl4 minus is there. Okay, so again here we will get the HCl plus AlCl3. So this is the catalyst AlCl3. That is why we are getting back in the reaction. So this is the all about the reaction mechanism. So if you wanted to take the screenshot of this, you can take the screenshot of it, because you will not get the reaction mechanism in any of the book, because it is the patentable, and you can save this. Rest of the reaction mechanism is available on the net, but this is not available in this format, and it is available in the patent, and patent cannot be accessible. So that is why we have designed this reaction mechanism. Okay, everyone.
Yes, sir.
Yes, sir.
Clear for this this reaction mechanism? It is very short, by the way, so that is don't worry about that, but still you need to practice it. Now regarding the procedure is also very short, and it is easy to prepare, by the way. It is easy to prepare. So what it is taken, that first of all AlCl3 is the solid. So AlCl3 is taken in the CH2Cl2, that is the MDC, that is the solvent, and in the same container you can take the benzoyl chloride. This is highly exothermic reaction, by the way. Okay, so in this case, what will you do, that you can take this in the RBF, introduce the MDC, introduce the benzoyl chloride, and then AlCl3. Okay, and put this in the ice bath, 0 to 5 degrees Celsius temperature. Put it into the ice bath, because the benzoyl chloride is very reactive, and this reaction is very highly exothermic reaction. In one of the thing, it is also written that you may take the CCl4 as a solvent. CCl4 can be taken as a solvent. Now, after mixing all these things, AlCl3, MDC, benzoyl chloride, and CCl4, now in the same container you can introduce the toluene. Same thing can be introduced in the flask with the toluene. Now toluene is also liquid. This is also liquid. So now in this, all the 4 things are there. What are there? 5 things are there: AlCl3, MDC, benzoyl chloride, CCl4, and finally the aniline. Toluene. Now keep this whole thing in this. Keep this reaction mixture at 0 to 5 degrees Celsius temperature for 20 minutes for the completion of the reaction. After the 25 minutes or 20 minutes, you can put it at room temperature. So you can put this for the 5 to 10 minutes at a room temperature, this whole reaction mixture that you have taken out from the ice bath. And finally you can add the HCl. You can add the HCl. So now you can filter off it. You can filter this so that here you will get all the impurities and rest of the solvent in the beaker, and here you will get the crude product, and that is the white product. It is the white product. So this is the procedure to prepare the 4-methyl benzophenone. Okay, so once again I am just explaining you so that it gets clear for you within a very short manner. You can take the RBF in the ice bath. Now introduce AlCl3, then CCl4, then MDC, methylene dichloride, and then benzoyl chloride. Keep it for 5 to 10 minutes here. Now you can introduce the toluene at the 0 to 5 degrees Celsius temperature itself. Keep this at 20 to 30 minutes at ice temperature. Take out from the ice bath and put it at room temperature for 5 to 10 minutes. Now you can add the HCl at room temperature itself, and finally you can filter off, so you will get the white crystals here. You can discard the filter and you can go for the recrystallization of the white product, crude product, and that can be like you can use acetone or methanol or ethanol. So in this way you will get the crystals. So here we have completed the 4th reaction and reaction mechanism and method. So I hope that it is clear for you about the acetylation. So we have utilized the acetic acid as an acetylating agent, benzoyl chloride as an acetylating agent, and acetic anhydride as an acetylating agents. So these 3 acetylating agents are utilized. Whenever you utilize acetic acid as an acetylating agent, it is mandatory requirement of the Zn dust. You may use ZnCl2 or Zn dust. Zn dust is more preferable, but when Zn dust is dissolved in the HCl, ultimately it gets converted into ZnCl2. But Zn dust is more feasible. So this is all about the reaction mechanism of the all the 4 reactions. So my dear students, here I have completed all the 4 reactions. First one was preparation of acetanilide from aniline. Second one was preparation of res acetophenone from resercinol. Third one was preparation of aspirin from salicylic acid. And fourth one was the preparation of 4-methyl benzophenone from the toluene. And all these 4 reaction mechanism and reactions are based on the acetylation. So if you are having any doubts, then now you can ask. You can ask if you are having any doubts.
Like sir, you said Z powder is more preferable. Why so?
Yes.
Sir, you said now okay, Zn dust is more preferable in a reaction.
Correct.
So what's the reason? Like just
see, Zn dust provides the catalytic property, and catalytic properties, for catalytic properties it provides surface. So Zn dust provides the more surface. so it absorbs the carrier very easily. So that is why Zn dust is more preferable. It looks like a charcoal dust. Okay, it looks like a charcoal dust. So that is why it is recommend to use the Zn dust. Yes. Who else?
हेलो सर.
Yes, sir.
यस सर, हम वो रेस एसिटोफिनॉन में कोई और रिएजेंट यूज कर सकते हैं रिएक्शन के लिए?
और reagent means what?
मींस एसिटिक एनहाइड्राइड या दूसरा कोई?
Of course.
सर, या फिर सर उसमें एस्टर बनने की पॉसिबिलिटी है ना?
हाँ,
अल्कोहल और एनहाइड्राइड रिएक्ट करेंगे तो मींस के एस्टर बनने की पॉसिबिलिटी है ना?
see, in res acetophenone, what have you utilized to prepare the res acetophenone? Acetic acid.
Acetic acid ZnCl2.
Okay, you have utilized the ZnCl2, is it?
Yes.
So ZnCl2 or Zn dust is utilized as a catalyst.
Okay, sir.
Correct. So here acetylating agent is what? That is the acetic acid.
Yes, sir.
Is it? So in place of the acetic acid, you may utilize acetic anhydride.
Okay,
that
sir.
is not an issue.
Okay.
But issue is
Thank
what?
you, sir.
All the colleges does not have the license of the acetic acid.
Yes.
So that is why we are also asking you to prepare with both the methods by using the acetic anhydride, or you can use the acetic acid.
Okay, sir.
Is it? So so that is there. Even you can utilize the acetyl chloride. That is
Yes.
also there.
Thank you, sir.
Yeah. Who else? Is there anything to discuss? Okay, fine. So I think now you people does not have any questions. So now I am completing this session here. So thank you so much for attending this session, and you have acquired the knowledge from this part. And I think tomorrow or day after tomorrow you are having exam for the practical. So there will be few questions from these 4 methods. So it is freshly in your mind. So you can read it properly. And also I will share the link for your reference so that it might be more easy to you. And you can Google it, or you can use the Vogel, AI Vogel, so that everything is detailing in that. So it is more feasible. But for your support, I will share that thing also. Otherwise, online AI